shizzle. Today we're going to be taking a look at something called the Little formula. So our goal for today's lesson is I can switch the equation of a parabola from standard form to vertex form by using the Little formula. So in our last lesson, we learned how to change from standard form to vertex form by completing the square. And by the end of that note, you guys were quite good at completing the square, but we did talk about how there are a lot of steps involved in that. So the Little formula is a little bit shorter for us, and it's helpful because of that. So this is another way that we can change standard form into vertex form. And the Little formula, when you use it, it gives you the x value for the vertex. And this is our Little formula. Okay, so the Little formula, x in the vertex is going to be equal to minus b over 2a. And once you find the x value, you can use that x value to find the matching y value by using substitution. And once you find the y value, then you have the coordinates of the vertex. And we know how important the vertex is to everything else connected to the parabola. Okay? This method will work for any quadratic equation that's in standard form, but it's especially helpful when the a value is not equal to 1 out in front of the x squared in the equation. Because when we get a number out in front that is not equal to 1, as we found when we did completing the square, there's extra steps there. We have to divide things by that, and then it just makes it a little more difficult to do. So here are the steps that we use when we are using the Little formula. We won't read through these right now, but they're listed there. They're listed beside each question down below here, so we'll just kind of follow the steps as we work our way through. So in example 1 here, state the quadratic function in the form y equals a bracket x minus p squared plus q, so vertex form. And once you have it in vertex form, then they want us to state the vertex, the maximum and minimum value, and where it occurs. So just like we did in completing the square, it's going to be important that we identify the values of a, b, and c at the start. So in this case, you can see in the equation a is equal to 1/2, b is equal to -5, and c is equal to 10. So there are our values for a, b, and c. Now we're going to solve for x using the Little formula. I'll write down my Little formula. So that's step 1 there. This is step 2. So my Little formula is pretty little, so you should be able to remember it. So minus b over 2a. So my b is -5. So if it's minus b, it's minus -5. And then on the bottom, I've got 2 times a, so 2 times 1/2. And so -5 is going to be +5. And 2 times 1/2 is equal to 1. So this gives me the x value in the vertex. So in the third step, I'm going to substitute that into the equation and figure out what y is. What's the other part of the vertex point? So let's see. I'm going to have to make a little bit of room here. Slide these guys over. A little bit more room. Awesome. Draw a little line down here, so that's right. Okay. So I need to substitute x equals 5 into this equation up above. So y equals a half 5 squared minus 5, and x is 5, and then plus 10. All right, so 5 squared is 25, and minus 5 times 5 is minus 25, and then add plus 10. So y equals a half of 25. You can just write that as a decimal here. Okay, and then when we add all those up, we end up with y equals negative 2.5. So once we know our y value and our x value, that means, therefore, the vertex is 5, negative 2.5. And we also need to know a in order to write the equation in vertex form. And a up above here is 1 half. So if I'm going to write this equation in vertex form, so there's our formula for vertex form. So it's going to be y equals a is going to be 1 half. And remember that we've got P and Q here. So we've got A, P, and Q that we're subbing in. So our X here is fine. And then minus P, so minus 5 squared, and then minus 2.5 goes on the end. Minus 2.5 on the end. Okay, so there's the vertex. And it opens up. So the vertex is a minimum point. So the minimum equals negative 2.5 when x equals 5. So there's that answer, and there's what it looks like when we write it in vertex form. All right, let's try another one here. So first thing you want us to do is change the vertex, or change the function up above here into vertex form. So we're going to start by let's make a list of our A, B, and C here. You'll have to use those again. And then for part A, we're going to use the little formula to start with. So x equals, it's going to be minus 16 over 2 times negative 2. So negative 16 divided by negative 4, x is going to be equal to 4. Okay, so we'll sub in x equals 4. So in our equation there, minus 2x squared plus 16x minus 3. Okay. Oh, sorry, that's a plus 16. And a minus 3. Mixed up my signs there, that's not good. All right, so now I'm going to sub x equals 4 in. It's going to be negative 2, 4 squared, plus 16 times 4, minus 3. And when I calculate these, 4 squared is 16, times minus 2 is going to be minus 32. 16 times 4 will give us 64, and then we have minus 3 on the end. So when we calculate our answer, we get y is equal to 29. So we've got our x value, and we have our y value for our vertex. Okay, so vertex is 429, and A is equal to, and remember A is that value that's right in front. So A is equal to -2. All right, so take that information up top, see if we can use that to write. Now we want to write the equation in vertex form. So y equals, remember that's our P, our Q, and our A. So y equals -2 x minus 4 squared. Just going to make that a little clearer. 4 squared and then plus 29. Okay, so the other information they want, this parabola opens down. The vertex we've already stated is 429. The equation for the axis of symmetry, remember it's always x equals, and we get that from the vertex, the 4. And this parabola opens down, so it has a maximum value of 29 when x equals 4. Okay, one last one to try here. Okay, and we'll do a little bit of graphing here as well. So for this one, we'll start with our little formula. So we got -2, 12, and -10. So x equals -8.
Matt Osborne comes to PLC. Matt Osborne to PLC.
So I got -12 on top and then 2 times a, so 2 times -2 on the bottom. When I solve that, I'm going to get x equals 3. I'm going to sub 3 into the equation, so whoops, go here. Okay, so it's going to be y equals -2, 3 squared plus 12 times 3 minus 10. When we calculate this, we get -18 plus 36 minus 10. So we end up with y equals 8. So our vertex is 3, 8. A is equal to -2. And so the equation is y equals, and then A goes first, and then x minus p, so x minus 3 squared plus q, which is 8. So for this one then, we know that the direction of opening, it's going to open down because of that -2 out in front. C, the vertex we've already mentioned, is 3, 8. Our axis of symmetry is x equals 3 from our vertex. D, our maximum is equal to 8, and that's when x equals 3. And the last thing here that's pretty helpful for graphing it, the step pattern, because A is -2, it's going to be -2, -6, -10. So I'm going to plot my vertex. So I'm going to go over to 3 and up to 8, and then I count my step pattern from there. So over 1, down 2, over 1, down 6, over 1, down 10. So we don't need to put that one on there. It's going to be off the graph. I'll do my points on the other side of the vertex here. So my points are there and there. And then I can draw my parabola through those points and put my arrowheads on there. Okay, so practice this tomorrow in class, and then we'll be moving on to one other form of quadratic equations. Thanks a lot.